Hey everyone, welcome to our lesson on quadratic functions in intercept form. We're going to take a look at what intercept form looks like first so that we will know when we have our quadratic in that form. Then we're going to take a look at how to get our quadratics to that form, talk about graphing and some characteristics when we're looking at that form. So this is what intercept form looks like. It's the broken down into groups way of writing our function. It's also called factor form sometimes. We're going to see our a value, our coefficient that stretches or shrinks the graph first. Then we should have x minus each intercept. So it's called intercept form because we can see the intercepts here. Okay, so we talked about other names of intercepts are the roots, the solutions, and also can be called factor form. So let's get started. Let's say we have a standard form quadratic and we need to get that into intercept form. What we're going to do is we're going to use factoring to do that because we need it to be broken down into those factors to write it in this form. So a quick recap on that is we need to find two numbers that multiply to give me my last term here, -3, and then also add to give me my middle term here. That's factoring. So if you think about some numbers that would make a product of -3, that would be -1 and 3, or maybe 1 and -3. And let's figure out which one is going to add together to give me -2. Looks like it's going to be this second one here. 1 plus -3 gives me -2. So that's what I'm going to fill in for intercept form. So I'm going to have x minus each one of these. Okay. I'm going to fill in my factors 1 and -3. And to find the roots, the actual roots from this, what we could do is we can set them equal to 0. So if x plus 1 equals 0, that means that that x value is -1. That's the root. And then if x plus 3 is 0, x minus 3 is 0, that means that x equals +3. So these right here are our roots. And this over here is intercept form that matches those. All right, so we used factoring to do that. So here's our intercept form, x minus 3, x plus 1. Make sure that matches, yes. And let's pause here and know that if you ever needed to get back to standard form from intercept form, you could simply just FOIL out, use the FOIL method of multiplying what you see and simplify, and then you would be back to standard form. And we are going to need our standard form for finding the vertex in just a minute. All right, so we identified the intercepts, 3 and -1, from setting these equal to 0 and solving. So we're going to remember that our intercepts are those values. And now, moving forward, we're going to be graphing this, so we're going to need to know the vertex as well. So remember I told you how to get back to standard form if you needed it was to FOIL out your intercept form. So let's go back to standard form so we can find the vertex from that. So if we had x squared plus x minus 3x minus 3, this is using the FOIL method, x squared minus 2x minus 3, what we can do to find the vertex is take the -b value over 2 times a. We have in standard form our a and our b and our c in order here. So I'm going to take -b, my b is -2, so -2 over 2 times a. Notice there's not a number there. So when that happens in front of a variable, there's an implied 1. I'm going to use 1 for a. So what's this give me? This gives me +2 over 2, which is 1. And then to find my matching y value of the vertex, I'm just simply going to plug that back in and see what comes out for y. So in our equation, let's go back to our blue color, x squared minus 2x minus 3. I'm going to put in this 1. See what comes out. So 1 squared minus 2 times 1 minus 3. I've got 1 minus 2, which is -1, subtract another 3, negative 4. So we have a vertex of 1, negative 4. All right, so we know a good deal about this graph now. We know some intercepts and the vertex. So we can go ahead and graph once we have those key pieces. Our vertex, again, was 1, negative 4. Let's go put that on the graph because that's going to be the center of our quadratic. And then remember our intercepts that we found, our x-intercepts located at 3 and at negative 1. I'm just going to put those right on the x-axis because that's where they're crossing the x-axis. Our quadratic was positive. In the very front, there was no negative sign, so we know that that means it's going to open upward. And I could see that from the points. I just wanted to reiterate that fact that if you don't see a negative out there, it should be opening upward. So here's our graph that we just created from intercept form using only those in the vertex. So let's recap what we did here. We were able to find intercept form, first of all, from standard by factoring. And if you need to go back to standard, you can always multiply those factors back out. We found the intercepts, and then we found the vertex using negative b over 2a and plugging that back in. We graphed all three things connected, and we had a nice quadratic. So this concludes our lesson on quadratic functions in intercept form.